This is going to be our lecture video for May 1st. Going to go over just a quick couple of problems before you take the quiz today. Hopefully these will help you out. Starting with this do now, explain why we need to include the plus 2 pi n to the end of our solutions to inverse trig problems. So let's have a little example to help guide our answer here. So if I'm doing something like the inverse cosine of 1/2, what's happening here is that I want, so equals theta, to represent all of the angles that have an adjacent over hypotenuse of 1/2. The first one I can find is, let's see, if I make the adjacent 1 and the hypotenuse 2, that's our 1, 2, and the square root of 3 triangle. That's a 60 degree. Well, we're going to say pi over 3. All right. So I want to represent all the angles that have an adjacent over hypotenuse of 1/2. The first one I can find is pi over 3. From this terminal side, if I add 2 pi, I will return to the same spot. Therefore, pi over 3 plus 2 pi n, or we'll just say plus 2 pi for right now, has the same trig ratios as pi over 3. And so will all coterminal angles. Plus 2 pi n represents that I can take any solution and add multiples of full revolutions to get coterminal angles which are additional solutions. All right, and the last thing I'll say about this is that pi over 3 plus 2 pi n isn't the only solution to this. There's another place down here in the fourth quadrant at, what would that be? It's a pi over 3 short of 6 pi over 3, so it's 5 pi over 3. Yeah, at 5 pi over 3, where we get that same ratio again, but that's not the question's asking. It's asking about why we always do this plus 2 pi n, where n is an integer. Why we always add that to the end of our solutions. It's because once we find one solution, you can get all of the solutions by just continually rotating that terminal side back around to be in the same spot. The goal today is to demonstrate our understanding of verifying true identities on today's quiz. While we're doing this, verifying identities often requires us to try multiple pathways and to think ahead and creatively. Also in that quiz are a few solving problems. So let's practice those right now. All right, can we solve for x in the following? What value of x will make this true? Negative cosine squared equals negative sine squared plus sine. All right, so one thing is I want one side to be equal to 0, so I'll move the term on the side with the fewer terms. Add a cosine squared here. Now I've got 0 equals negative sine squared x plus sine x plus cosine squared x. So next thing I want to focus on is getting these to all have the same trig function. So I can either go all sine or all cosine, but it's going to be easier with the cosine squared to turn that into a sine squared, because this identity, sine squared plus cosine squared equals 1, directly relates sine and cosine. All right, there actually isn't a great identity that directly relates sine and just sine and cosine without the squareds. You have to use like a co-function identity or go through tangent. That's not as fun. We're just going to use this. So if I subtract sine squared from both sides, I get that cosine squared is equal to 1 minus sine squared. I can use that, substituting right here. So 0 equals negative sine squared x plus sine of x plus 1 minus sine of x, or sine squared x. Let's go ahead and combine like terms. So now I've got 0 equals negative 2 sine squared x, these coming together, plus sine of x plus 1. Now I want to factor this, and I just kind of treat sine like a variable that's just coming with for the factoring. Actually, I don't like that negative in front. I'm going to divide everything by negative 1 first. 0 divided by negative 1 is still just 0, but now I've got 2 sine squared x minus sine of x minus 1. All right, so I set up simple factoring, but I do it with a 2 sine, so that when I do sine of x times 2 sine of x, I'll get a 2 sine squared x. And now I just have to figure out what number I need to put here so that they multiply to be a negative 1, and then this times this plus this times this adds to be negative 1. So let's just think about that for a second. I think I want to put the minus 1 here and the plus 1 here. Yeah, that works out. All right, this is still equal to 0, so I can use the 0 product property to say 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. All right, we'll solve these separately. Now I'm trying to get the sine by itself, so I can move things to the other side. 2 sine of x equals negative 1, divided by 2, divided by 2. Sine of x equals negative 1/2. Now that I've got down to trig function equals a fraction, I label that fraction with whatever the trig function is. This one's opposite over hypotenuse. So where can I draw a triangle that's got an opposite of negative 1 and a hypotenuse of 2? There's 2 of them. They're over here. The 2 places where sine is negative. Nope, that's not true. The 2 places where sine are negative are here and here. All students take calc. These are the 2 where sine is negative. Here now the opposite is negative 1. And the hypotenuse is 2. Meaning that this side length here must be the square root of 3. Technically this one's negative. The side opposite of the 1 is always the 30 degree. And this 30, 60, 90. And I want to give my answer in radians, so that's pi over 6. So this angle here is 7 pi over 6. This one here is 11 pi over 6. just short of the 12 pi over 6, which would have been 2 pi. Both of those get a plus 2 pi n, but let's go finish solving this one. I add 1 to both sides. Where is sine of x equal to 1? Where on my unit circle is sine of x equal to 1? Alright, so we need the opposite over hypotenuse to be equal to 1. So it's got to be right here. Because the flat triangle I would draw would have an opposite and a hypotenuse that are both 1. I can try and draw just a real skinny triangle in here. And 1 over 1 equals 1. So that angle there is pi over 2. Alright, so now I'm going to write down all my answers. X equals, I'll go in order, pi over 2 plus 2 pi n. 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n, where n is an integer. All right. Last one. What value of x makes this one true? Sine of x equals 4. So I can try taking the inverse sine of both sides. Canceling the side, I get x equals the inverse sine of 4. Let's go ahead and make that a 4 over 1. So now I can try and draw a triangle with an opposite of 4 and a hypotenuse of 1, but it's not going to work very well. So here's my right angle. Here's my angle. Well, we'll say theta. How do I want to do this? So theta is right there. All right, so the opposite is 4. So this length here is 4, but this length here is only 1. So it's never going to reach. Even if I scooch this side all the way in, I can never get this point all the way up to this point. So it's an impossible triangle. One thing we've said is that the hypotenuse always has to be the longest side. Well, here it's not the longest side, so this is an impossible triangle. Therefore, we get no solution. Another way to think about this is that we've got a sine wave, which we know starts at a minimum, or at the midpoint, goes up, back down. And what we're asking with this problem is, when does this sine wave cross a horizontal line that's up here at 4? Well, the highest it ever goes is 1, and then it turns back down and goes down to -1. And I don't care how far out we draw this, it's never going to go up to 4. So that's another reason why we have no solution. All right, we'll call that good for this one. Good luck on that quiz. Have a good rest of your day.